Okay. All right. So the first question, the first question says, in a sale, the normal piece or price rather for a book of a book is reduced by 30%. The sale price of the book is £2 80 uh, pence, and it says work out the normal price of the book. Okay, so typically questions like this would give us the normal price of the book and then ask us what was the sale price. Okay, so this is more like working backwards, right?
Yes.
So if that's the case, then we need to have in mind what we're working backwards against. So I'm going to let me just do this. Let me put up a whiteboard beside your. Um, so I'm going to just put up a whiteboard, new whiteboard. Oh, this is not finished. In a minute. Don't worry. Okay, I'll just do things. Hey, all right. So I'm going to put my own screen beside yours so that you can see what I'm sharing too. Uh, okay. It didn't stop your share, did it?
No, I'm still sharing.
Okay, good. All right. So, but can you see my screen?
No.
Okay, you can't see my screen, right?
Oh no, I can see it. I can see it.
Okay, no problem. Let me. You can see it. Okay, great. Okay. All right. So this is what I wanted to say, or this is what I was saying. Um. The sale price. Let's just call that. Okay. No, that's not nice. Let me make it quicker. Okay. Okay. So the sale price, right, is let's just say SP. The sale price is usually given by if there's a if I think the ones that we have worked together so far in the past were increments. Okay, so yeah, somehow there was an increment. Whenever there was an increment, we would add the percentage to 100. Do you remember that scenario?
Yes.
Okay, good. But now there's a decrement, so we're going to decrease. We're going to subtract that from 100. So I think the question says 30%, right?
Yes.
Okay. So if I take 30% out of 100, that's going to leave me with 70%. So 70% is the same thing as 0.7. Okay. Actually, 0.70, which is just as good as 0.7. Okay. Now, uh, times the original price, what the question calls the normal price. So let's just call it NP. And the NP is what we're looking for. Okay, so remember, what we're looking for is NP. And anytime we have a number multiplying what we're looking for, to find what we're looking for, we will divide both sides by the number that's multiplying what we're looking for. Okay, so what that means is that NP will be equal to SP over 0.7. Do you agree with that? You know what? You understand? You understand what I'm doing, right?
Yes. You're rearranging the formula.
Okay. Did you understand what I did to get to this point?
Yes.
Excellent. All right. So what we will now do is to put in the value. So SP is 2.80. Please confirm if I'm correct by the question.
Yes.
It's 2.80. Okay, good. So 2.80 divided by 0.7, and we see we have some good numbers here that can take themselves out. So remember, anytime you are dealing with decimals in uh, division, what do? You try to make them whole numbers, but it's always advisable to start with the one that has more decimal points, more decimal places. And if you look at these two numbers, the one that has more decimal places is 2.80, which, well, we could have as well left it at 2.8. So maybe I should just do that. Let's just summarize it to 2.8. So, yeah, let's just leave it at 2.8. All right. So this decimal point will move one place to the right hand side, leaving me with what? 28. Of course, whatever I do to the numerator must also be done to the denominator to balance it up. And so that will give me what? 28 over 7, which is 28 divided by 7 is what? That's going to be 4. Okay. Are you good with your 7 times table?
A little bit, yes.
Yes, okay. So it's 4. 4 times. So that will just give me 4. So the normal price is 4. It's going to be 4 pounds, I think. Yeah, because the question, the sale price was in pounds. So it was 4 pounds. Okay. So I'm going to stop sharing when we need it again. But are you good with my workings?
Yes.
Okay. All right. So should I go ahead and stop sharing?
Yes, yes.
Okay. All right. Okay. So let's see the next question. The next question says Brogan needs to draw the graph of y uh, equals x squared plus 1. Yeah, okay, yes, x squared plus 1. Okay, here is her graph. Okay, and this is her graph. So it's supposed to be a curve, but it looks like the points are too sharp. She said, if the question now says, write down, I thought as much, write down one thing that is wrong with Brogan's graph. So ideally, any quadratic equation, right, that has the highest, of course, the quadratic equation, the highest power of x is always 2. Okay, when I say x, I mean the independent variable. Okay, so the independent variable usually is the one that's on your x-axis, while the dependent variable is the one on the y-axis. So the dependent is usually defined in terms of the independent variable. Okay, so in this case, x is your independent variable, and whenever the highest power of x will tell us what kind of graph that should be. So anytime you have 2 as the highest power of your independent variable, in this case x, the graph must be a curve. Okay, so you can see clearly that this graph is not a curve. So we're going to have some issues with getting accurate points, okay, and precision. So that's one thing I would say that's wrong with this graph. It's not taking into consideration that it's a curve that we're expecting. All right. So it's not, values won't be accurate. Okay. If we were going to draw it, it's supposed to curve like a V shape, like a curvy V. Okay. So I don't know if you understand my explanation.
Yes.
All right. Do you want us to check with the marking scheme if there's any other points that they took note of? Or that's the points I have taken note of. That's the thing I've seen that's wrong with the graph. Does the marking scheme say anything extra?
Mm, let me just find the papers, man.
Okay, okay.
Yes, it just says the same thing, that it should be curved.
So it should- right? Okay. All right. So I think that's it. We can proceed to the next question. All right. So this is a rectangle. It says all measurements are in centimeters. The area of the rectangle is 48 centimeters or square centimeters. Show that y is equal to 3. Okay. So you want to give this one a try?
Um, okay.
Okay. So now let me just point out something here. If you take a look at this rectangle carefully, you will see that the side have one of the sides has y and the other side has x. So it's usually I'll not say it's a pretty tricky question, but if you're not careful, you may find yourself uh, 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 bumping into a simultaneous equation. Simultaneous equations usually have more than one unknown, and you want to solve them. But if you look at this guy carefully, I'm sure you'll be able to figure a way out. So if I may ask, what's the first thing you are going to do if you are faced with this question? What's the first thing you're going to do?
Um, add up the like terms.
When you say add up the like terms, why are we adding? Because the question said the area, not the perimeter.
So you don't
Did
add up
you
the
get
like
that? Okay, what I didn't hear what you said back then.
So I'm adding the like terms, right?
No, no, we're not adding terms, right? Just quite yet. But we need to, you know, whatever you are going to start with, you need to give a reason for why you are starting with it. So I think I get where you are going to, but I want to be really sure. What's your basis for adding the like terms? There's a first step that should be here. So let's have the first step out. What's the first step? What's the first thing you should do before you start thinking about adding the like term or subtracting in any case?
Yeah, I don't know.
Okay, so remember these properties of a rectangle, right? The opposite sides are equal. Okay, so if the opposite sides are equal, on that basis, 2x plus 6 will be equal to 5 minus 9. Did you get that now?
Yes.
Okay, so I want you to write it down. 2x plus 6, then put an equal sign. 5x minus 9. The reason you can put in bracket, opposite sides are equal, right? Now, on the next line, we're going to have, you cannot collect like terms, right? If I were going to do this, I think I'll take, maybe I should just do it. Let me share my screen again. Let me share my screen. I'll share that page that I was working on. Okay, can you see my screen now?
Yes.
Okay, excellent. Okay, so I'm going to quickly draw a line this way, and I'm going to say, wait a minute. Okay, so I wanted to move this. Okay, so maybe you just, let me just confirm that this is the correct thing. 2x Okay, it's pretty. I'm trying to write. Is it 2x minus 6?
No,
I don't know.
2x plus 6.
2x plus 6. Okay. All right. So 2x plus 6 equals, it's, I know there's 5x somewhere. 5x, what comes after the 5x?
Minus 9.
Minus 9. Excellent. Okay. So usually, of course, it's cooler to collect the like terms in such a way that you will avoid um, negative numbers as much as possible. But it's not, you can't always guarantee that it will be perfect. So what I'm going to do now is take 2x to the right hand side. Okay. And I'm going to take minus 9. Please don't forget the sign in front of the numbers, especially when it's a negative sign, matters a lot. Okay. So please don't forget this minus sign in front of 9. Okay. So minus 9 going over to the left hand side will become what? Plus 9. So this is what I'm going to have. 6, because the 6 didn't move, the sign in front of 6 is still positive, but the 9 moved. So the 9 coming to the left hand side is positive because it was negative on the right. Sorry for that. Okay, let me just, because it's now looking funny. Okay, so the 5x didn't move, but guess who moved? 2x. So 2x coming over to the right hand side will become minus what? 2x, right?
Yes.
Okay, so what's going to happen? What's on the left hand side? This is 15, isn't it? 15
Yes.
equals what?
3x.
3x. Thank you. So that means x will be what?
5.
5. Thank you very much. So x is 5. But they didn't ask us for x. The question asks for y. So what do you think we will now do? So see, that's another tricky thing. We need to be careful. So we found out that x is equal to 5, no doubt. All right, so now let's find y. Now remember, the question gave us some information about what? The area, isn't it? It tells us that the area is what? Do you remember what the question said? The area is 48. Am
48.
I right?
Yes.
Thank you. Good. Now, you know what we're going to do to find y? Very, very simple. Area of a rectangle is given by length times breadth, isn't it?
Yes.
Thank you. So that means that the area of that rectangle, which is 48, let me write it down, is going to give us an equation we can use to solve for y. The area of that rectangle, which is 48, is going to be equal to what? Y times, now, you can choose any of the sides. That's the good thing about this question now. You can choose either 2x plus 6, that's the length, or 5x minus 9. That's any of the other sides that are, you understand, length times breadth. Did you get do you understand what I'm trying to say?
Yes.
Okay, so which one should we use? 2x plus 6? Would 2x plus 6 fly?
Yes.
All right, good. So let's quickly substitute. 2x plus 6 will give us 2 times 5 plus 6, which is 10 plus 6, which is what? 16. Okay, excellent. So what will y be? Y will be given by, remember that principle. You're looking for something and something else is multiplying it. Divide both sides by that thing that's multiplying it. So you're simply going to say that y will be equal to 48 divided by 16. Okay, so 48 divided by 16 will be what?
So y equals 3.
Yes, right. So y is equal to 3. So y will be equal to 48. I'll just put it slash 16. Okay. All right. I think we're good to go with that question, and we can move on to the next one. Do you have any questions on this?
No.
And I think the unit is centimeter, if I'm right. So let's not forget that. Okay, so I'm going to stop sharing and hand over to you. All right. Okay. Are you writing down the workings or you
Yes, yes, I have my book.
okay, okay, good. All right. Okay, so let's move on. It says the table shows information about weekly earnings of 20 people who work in a shop. Okay, it's giving a frequency, blah, blah, blah. Work out an estimate for the mean of the weekly earnings. Okay. All right. So whenever you have things like this, I think this is like information that is used to plot either a histogram or one of those statistical things that like a cumulative frequency graph, something like that. So I think it's a histogram. I can't remember the other. There's another one um that has that has a name similar to it's in that class of histogram. So what we will do, because they gave us a range, we can't, we don't know the exact value. For instance, x is between 150 and 250. It can be any number in between those two numbers. So what we usually do is to find the middle position. Okay. So how do we know the middle position? This is what we are going to do. We'll say 150 plus 250 divided by 2. Now, sometimes it's usually easy to tell. Okay. Now, 15 plus 25 will give us what? 40, isn't it?
Yes.
So that's 400 technically. 150 plus 250 is 400. You divide it by 2, you have 200. So that means 200 is what in between 150 and 250. With that in mind, I can now make up my mind about the rest. So for the first one, the midpoint is 200. For the second one, the midpoint is 300. For the third one, the midpoint is 400. For the fourth one, the midpoint is 500. And for the fifth one, the midpoint is 600. Do you agree with my steps so far?
Yes.
Okay. Now, remember, the reason for getting the midpoint is because there's no way of telling what the exact value is. So our best bet is to get the midpoint. Now we know the midpoint. Guess what we're going to do next? Do you have an idea?
No.
Okay. We're going to multiply each of those midpoints by their individual frequency. What does that mean? We're going to, for instance, the midpoint for the first one is 200, right?
Yes.
Okay. So we're going to take 200 and multiply 200 by 1. So this one we're going to have. If you're writing it down, just help me write it down there. 200 times 1, put that in a bracket, plus 300 times 300 times 11 in a bracket 2, 400 times 5 in a bracket, 500 times, which of course obviously will cancel itself out, and then 600 times 3. Okay. Now remember, we're not using calculators, so maybe let me share my screen and equally do it so that sometimes when you see these things, it kind of gives you a clearer picture of what to expect. Okay, so I'm sharing my screen again. All right, looks like this guy is should I let me just do a new one. Do a new one. He's going to ask me to save it. I know. So do I want to save it? Okay, let me just say save. Um, okay, I think I should just put it there. No, math. Okay, 1 minute, please. Math. what I mean. Like, okay, no, not one. Okay, so I have a new. Can you see my screen now? Hello, Noah.
Pardon?
You see my screen back there?
Pardon?
Can you see my screen now?
No, I can't see it.
How about now?
Oh, yes, I can see it now.
Okay. Okay. All right.
Yes.
Okay. Good. Okay. All right. So let me continue. So I think the question had the first one was 200, right?
Yes.
Okay. So 200 times one. Please just give me the frequencies. I'm not sure I can remember all of them now. The next one is 300 times what? 11? Am I right? What was the frequency for the second one?
400 times 5.
400 times 5, right?
Yes.
Okay. So I'm sure you can see these values. You can mentally take care of these values, right? Because we already know what 4 times 5 is. We know what 11 times 3 is. We know what 2 times 1 is. What's the next one? 500 times 0. Am I right?
Yes.
We already, this one is going to be 0 because anything times 0 is 0. Okay. And then finally, we're just doing this because of we want to show our working, nothing else. The last one is what? 600 times what?
Times 3.
Times 3. Okay, that's good. You know what 6 times 3 is? So guess what we're going to divide it by? You're going to divide it by the sum of the frequencies. So that's going to be 1 plus what? 11 plus 5 plus 0 and finally plus 3. I hope I didn't leave anyone out.
9.
I didn't. Okay. All right. So shall we? Remember, this is mental. Nothing to. There's nothing to use a calculator for. So I just have 200, and then I have what next? Plus 11 times 3 is 33. So I'll just simply put my 33 and put those two zeros behind the 300 behind it. As simple as that. Okay. Next, I have 4 times 5. That's 20. And with the 400, the two zeros behind the 4 in the 400 will just go behind 20 to make it 2000, right?
Yes.
All right. Of course, I'm going to skip this one unless you want to just put a zero there to acknowledge that as well it was there. But in otherwise, I would have skipped it. 6 times 3 is 18. The two zeros in 600 will make it become 1800. Okay. So can we add this up? 11 plus 1, 12, 12 plus 5, 17, 17 plus 3, 20. We said that 0 didn't exist. Actually, numerically, it doesn't count. Okay, so shall we add this up?
Okay.
3,300, that's 3,500, right?
Yes.
3,500, 2,000 will give us 4,500. 5,500. Okay, so now I know this one may be a bit crunchy, so let me just write it down there. 5,500 plus 800. So that's going to give me 5 plus 8 is 13. Let me just put the two zeros there. Two zeros there. 5 plus 8 is 13. 3 carry 1. And then 5 plus the 5 plus 1 is 6, right? 5 plus 1 is 6 plus 1, 7. Okay. I hope I didn't miss anything there. This is divided by 20, right?
Yes.
I'm going to be canceling this zero here. Will cancel one of these zeros here, leaving me with 2 down there. 2 can go in, do its job here one time. Now, let's go with this carefully. 2 in 7 will go there 3 times because 2 times 3 is 6, right?
Yes.
That will leave me with a remainder of 1. I'll put that 1, a small 1 there so that it doesn't look confusing. I'll put that 1 beside it. It becomes 13. 2 in 13 is 6. Because 2 times 6 is 12. Again, remainder 1. Put that remainder small 1 there beside the 0. That will make it 10. 2 in 10 will give me what? 5. So our mean is going to be what? 305. That's what it's going to be. Okay. So, did you get the workings there? I don't know. Are you still there?
Yes, I'm still here.
Okay. Okay.
Yeah, I've got to work.
Okay. All right. So, can I stop sharing now?
Yes.
Okay. All right. Okay. It says the diagram shows a logo made from 3 circles. Each circle has center O. Okay. Of course, all of them are sharing the same center, right? It now says Daisy says that exactly 1/3 of the logo is shaded. Is Daisy correct? You must show all your working. All right. So let's see if Daisy is correct. Now, for Daisy to be correct, we need to prove that shaded area is 1/3 of the whole area of the biggest the area of that circle, the biggest circle. Okay, that's what's going to show that um Daisy is correct. So let's do our best to find what the area of that shaded part is. All right. So of course we may need to understand that pi has been given to us. But guess what we're going to do? We're not going to. I'm going to do the calculation in such a way that we are not going to need the value of pi, the actual value of pi. So I'm going to show you how I'll go about that. But in the meantime, I want us to take note of because I'll be sharing my screen. And once I start sharing my screen, I don't usually see your own screen. But maybe if I move my own screen around, I'll see. But let me just take note of the dimensions. The inner circle is 4 centimeters by radius. And then that shaded place, and now that's not its radius, but that's the extra. Okay, after the 4 cm, right? That's 3 cm. Okay, so let me ask you, the innermost circle, its radius is 4 cm. What will be the radius of the second circle, the one that is the boundary for the shaded part? What's going to be its radius? I don't know. Are you there?
Yes.
So what's going to be the radius for that circle, the one that has the shaded part?
Pi or
What's the,
pi 3 squared.
I said, what's the radius? Just the radius. I didn't ask for its area, just the radius.
Oh, is it 7?
Thank you. It's 7. You see, it's very important that you know the radius first. Okay, now, of course, the radius for the bigger one is going to be 10, isn't it?
Yes.
Now we have things settled. Let's now get into the job of finding what the area of the shaded part is. Now, the area of that shaded part is going to be the area of the second circle, right, minus the area of the first circle, smallest circle. Do you agree with that?
Yes.
Okay. So now we know that. Let me share my screen. So let's just. I've taken note of it. Okay. All right. So please confirm if you can see my screen. Can you see my screen?
Yes.
Okay. So I'm going to move down a bit. So um so I said the shaded area for the shaded, let me just write that it's the shaded that I'm finding here. For the shaded one, I'll just write shade. I'm not sure I have that patience to write shaded. Okay, okay, let's just write shaded, but no area. Okay, for the shaded one, its area is given by pi r squared, right? Now, again, the area of the shaded part, that's that in that the shaded part is going to be the area of the second circle minus the area of the first one, the smallest circle. Okay, so that's going to be 7. Remember, pi r squared. Okay, so that's going to be 7 pi. Okay, remember I told you I'm going to do this without asking for the actual value of pi. Pi times 7 squared. Okay, so I'm just writing it as pi 7 squared. Algebraic notation that you put numbers that are multiplying themselves beside the letters that are multiplying. Okay, minus the area of the smallest circle, which is pi 3 squared. Okay, now I'm writing this down. I want you to confirm that you understand what I'm doing. Do you understand what I'm doing?
Yes.
Okay. Now, in case it tries to look a bit, hazy and confusing, I want you to just imagine that you took a scissors and cut out that smallest circle. You will see that when you cut out the smallest circle, and let's imagine that that bigger circle did not exist. If you cut out the smaller circle, you will be left with just the shaded portion, right?
Yes.
Okay. All right. So let's move on. So 7 squared is 49. So I'll have 49 pi minus 9 pi. 49 pi minus 9 pi. That's going to leave me with what? 40. Do you agree with that?
Yes.
Okay. I'm left with 40 pi. So 40 pi, but now that's not the we have not got to the final answer yet. But at least we have gone halfway. So 40 pi is the area of the shaded portion. Now remember, Daisy said that the shaded portion is 1/3 of the whole logo. Okay, for us to establish that she's correct, we need to find out the area of the biggest circle. So let's go ahead and do that. So the biggest, let me just write biggest. The biggest circle is what represents the whole logo. That's the whole idea. So
Pi 10 squared.
let me just say big. Thank you very much. So that's going to be what, 100 squared, isn't it?
Yes.
Okay, so I just have 100, let's say 100 squared. 100 pi, sorry, not 100 squared, please. Okay. So for Daisy to be correct, right? This guy, 40 pi divided by 100 pi, should give us 1/3. Do you agree with that?
Yes.
Good. But let's see. Something tells me that that's not going to happen. 40 pi, because 40 times 3 is 120, not 100. So there's no way 40 over 100 will give me 1/3. Can't happen mathematically and cannot happen any other way. So can you see what's happening here? Pi will cancel itself. That's for sure. This zero will take out this zero, right?
Yes.
Left with 4/10. 2 will go into 4 how many times? 2 times. 2 will go into 10 how many times? 5 times. And that's it. It's a wrap. And the fraction we have is what? 2/5, not 1/3. So Daisy is very incorrect. Do you agree with that?
Yes.
Okay. Any questions?
Um, no.
Okay. So can I unshare my screen now? I mean my whiteboard.
Yes.
Okay. All right. All righty. So we're moving on to the next question. Now I want you to see these instructions. Whenever they say you must show all your working, they are pretty serious about it. You need to show all your working. Please don't take anything for granted, because that's what's going to show that you actually did the question without using a calculator or any form of assistance. Okay, so what does it say about this one? ABCD is a parallelogram. Okay, let's look for ABCD just to be sure that we are there. Okay, it now says um, EDC is a straight line. Obviously, it is a straight line. F is the point on AD. F is the point on AD. So you see, as I'm reading this, I'm looking at the diagram just to make sure that everything they're saying adds up. F is the point on AD, so that BFE is also a straight line. Okay, what does it say next? Angle EFD is equal to 35 degrees. Okay, we've seen that. Angle DCB is equal to 75 degrees. That's also clear. It now says show that angle ABF is 70. That's 70 degrees. ABF. Okay. And they said we should give a reason for each stage of our working. Hmm. Okay. Hmm. Hmm. Okay. So let me see. Um. All right. First off, we know we're dealing with a parallelogram, right?
Yes.
Parallelograms and rectangles share some things in common. In fact, a rectangle is a type of a parallelogram. Okay, it's very, very safe to say that because opposite sides of a rectangle are equal and parallel. Now, we cannot say the same thing. Well, to some extent, we can say the same thing about the angles. Opposite angles in a parallelogram are also what? Equal. Okay, so this is what we're going to do. Now, just follow my uh, argument now. Reason for stage one of my working. Opposite angles in a parallelogram are equal. What that means is that if angle DCB is 75 degrees, then angle DAB, can you annotate on this one? Can you
Um,
annotate on this question paper?
No.
Will it allow you?
No.
Okay, it doesn't allow you to annotate. All right, no problem.
No.
No problem. Let's continue. But do you know the angle I'm calling angle DAB?
Yes.
That's why I was asking if we can annotate. Angle. Okay, I really wish you could annotate. But anyway, well, okay, so you can think about it as DAB, the angle at where the letter A is, right? So that means that we're trying to say we can safely conclude that the angle at where the letter A is 75 degrees. And the reason again is what? Opposite angles in a parallelogram are what? Equal. Did you get that?
Yes.
Okay, now that we know that that is 75, guess what? The angle at F, now I want you to look at F very critically. On the right hand side of F, you have what angle there?
45.
35. Thank you very much. Now, do you remember when I told you something about vertically opposite angles? Do you remember
Yes.
when we would ask those questions? Thank you. This is a classical example of vertically opposite angles being equal. So the second stage of your working now, you are about to conclude that angle AFB is 35. Reason: vertically opposite angles are equal. Okay, so guess what? We have a triangle. We already know two of the angles. Don't you think we can tell what the third angle will be?
Yes.
So what will be your reason for the last stage of your working?
Um, Angles in a triangle add up to 180.
Perfect. Perfect. So 35 plus 75, and then you get the sum and subtract it from 180. That is going to give you what ABF is. That's it.
70.
Okay. Yes. Okay. So are you good with this?
Yes.
Okay. Okay. So we can move on. Okay. Hmm. This one looks like a ratio question. What does it say? Kiaria. That name sounds special. Is 7 years older than Jay, and Martha is twice as old as Kiaria. It says the sum of their three ages is 77. It now says find the ratio of Jay's age to Kiaria's age to Martha's age. Wow, a threefold ratio. Okay, that's not bad. Well, if I were faced with this kind of question, you know what I'll do? I will assign a letter to the youngest person's age and use that letter and find the others. Now, let me look at it critically. Whose age should we assume is the youngest,
Um,
or the one whose own is in terms of the others? Who do you think is the youngest here?
J.
Yay, that's right. That's right. Because it tells us that Kiara is 7 years older than Jay. So you know what we're going to do? We're going to we're going to express all of their ages in terms of Jay's age. How about that? Let's see. Let's go out. Let's see how it goes. So um and you can take a look at the question. The question says find the ratio of Jay's age to Kiara's age to Martha's age. So somehow they've even helped you to arrange it in the order that you know it to make life easy for you. So we can start with J's age. Let's use the letter J for J's age, right? So we're going to say J, and then you have the ratio sign. You can write it down as I'm saying it. And you have the ratio sign. Kiara is 7 years older than J. J, maybe we should not, no, let's not even do the ratio yet. Let's do the addition first. J plus, in bracket, J plus 7, that's Kiara's age, plus, remember, Martha is twice as old as Kiara, right?
Yes.
Now remember, Kiara is J plus 7 years old. Okay, so that's going to be 2 into bracket J plus 7. Did you get that?
So 2 bracket J plus 7.
2, yes. Did you get that?
Yes.
Okay, now, you know what we're going to do next? We're going to equate, put an equal sign and put 77, because that's what the question told us, that the sum of their ages is what? 77. So are you good up to that point before I
Yes.
proceed? Okay, good. All right, so let's see what we have. Our equation will now become J plus 7 plus 2J plus 14 equals 77, right?
Sorry, can you repeat that again, please?
Okay, let me take it again. J plus J plus 7 plus 2J plus 14 equals 77.
Where'd you get the 2J from?
Remember,
The
Martha is twice
the
as Carrier.
the 2Js, like the 2 separate ones.
Yeah, no, the 2 separate ones have always been there. The other one, the 2J came from, remember, 2 into bracket J plus 7. Did you get that? Do you remember? Because it
Yes.
told us Martha's age is 2 times Kiara's age. And meanwhile, Kiara is J plus 7. So 2 times J plus 7 will give us 2J plus 14.
Okay.
Did you get that now?
Yes.
Okay. So, can you collect the license for me? What would you have? When you collect all the license, what would you have?
4J.
4J, good. Mm-hmm. What next?
14 plus 7.
14 plus 7. And 14 plus 7 is 21, right?
Yes.
Okay. So we now have 4J plus 21 equals 77. So what are we going to do next?
Subtract 21 from 77.
Thank you very much. That's it. And that's it. So we're going to take 21 to the other side and subtract it from 77. That will give us 56. Yeah. Yeah. That will give us 56. Okay. So you know what happens next, right?
Yes.
What are we going to do next?
4 divided by 56 equals 14.
Say it again. Let me hear you. What did it say?
4 divided by 6 equals 14. Sorry, 4 divided by 56 equals 14.
Okay, I think what you meant to say was 56 divided by 4, right?
Yes.
Okay, all right, good. So that's 14. All right, so good. Yeah, that's good. Now, let me just ask, I'm just curious. How did you get 14?
4 goes into 5 once, remainder 1.
Mm-hmm.
4 goes into 16 full times.
Perfect, 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 perfect. Excellent. Okay, so I guess you can now get the ratio, right? So if we have to write out the ratio, how are we going to write it? So that means J is 14, right?
Yes.
So the ratio of J's age to Kiara's age to Martha's age is going to be written as 14 is to 21 is to 2 times 21 will give us what? 42, right?
Yes.
Okay. So we're good to go. You have any questions?
Okay.
Okay. Okay. I think which of them should we do? Okay, let's see if we can just do 3 of them, hit at 3 of them quickly. For the first one, work out 2 over 5 plus 1 over 4. That's pretty simple. We have an LCM of 20, right? I think you
Yes.
can handle that one. Yeah, so you can handle that one. So I think for time's sake, I'll leave that for you to finish up. But let's move on to the next one. The next one says, write down the value of 2 raised to power minus 3. It's pretty simple. Remember, anytime you have a negative power of any base, okay, it's
Mm.
equal to 1 divided by that base, in this case 2, raised to the same power, but without the minus. So in this case, 2 raised to power minus 3 is equal to 1 over 2 raised to power 3, which is the same thing as 1 over 8. That's all. So if you want to take it to decimal, you can take it to decimal. If you want to leave it as a fraction, 1 over 8, you will still be correct. Okay, but do you remember that rule that I just stated now? It's a rule. It's one of the rules of indices.
Sorry, pardon?
I said, do you remember the rule I just stated now about a base raised to a negative power? Do you remember that rule?
The one goes over it.
Yes, 1 divided by the base raised to the power. Do you remember it? Because
Yes.
we have discussed the question like this before. Okay, all right. So, did you get the working, or do you want us to go over it again?
No. I haven't.
Okay, good, excellent. Okay, so 36 as a product of its prime factors. Well, if you look at 36, I mean, 36 is 6 times 6, right?
Yes.
So you can break down 6 into 2 times 3, 2 times 3. That's 2 squared times 3 squared. That's it. That's 36. Product of its prime factors. 2 squared times 3 squared. Okay. So I think we can move on if there's no other question. Okay. Which one should we do first? Okay, let's just do the first one, 20. It says Amy and Josh use a calculator to work out 595 over 4.08 squared. Is that squared? Okay, yeah, it's squared. Plus 5.3. Okay. And his answer is 27.1115. And Josh's answer is 271.115. Just a matter of decimal point. So it says one of these answers is correct. Use approximations to find out which answer is correct. So if we were to approximate, how would you go about it? What would you approximate 595 to?
600.
Excellent. 600. Okay, so let's keep that on top. What would you approximate 4.08 to?
Um, 4.
Okay, all right. Okay, so yeah, we could approximate it to 4 squared. Okay. Then what would you approximate 5.3 to?
5.
5. Okay, so let's see how it all plays out. So we have 600 on top. We have 4 squared underneath, and we know that 4 squared is 16. Then we have 5. Now, should we play around with that 16 a bit? Can we approximate 16 to 15? Or would we rather move it to 20? Would the margin be too?
Pardon?
You know, 4 squared is 16, right?
Yes.
So I'm just thinking, do you think we should approximate it further to become 15?
Yes.
Okay, this is the whole idea. When you now have 15 plus 5, 15 plus 5 is 20, right? 20 into 600. That's going to give us what? 30, right?
Yes.
Of these numbers is closest to 30. 27.115 or 271.115. Which one is closest to 30?
27.1115.
So that means Ami's answer is correct. You agree with that? You agree with that, right?
Yes.
Okay. Okay. So can we move on to the next one now? It says work out 0.06 times 0.0003 divided by 0.01. Give your answer in standard form. Okay, so this one is an interesting one. What are we going to do to work this? So this is how I'm going to do this question. If I were to do it right, I will change all of them to standard form. So let me share my screen. Let me share my screen so that I will not just be speaking. Okay. Don't share your own. No. I just want to share the. All right. So do I still have space under? Okay. Let me see if I can use this space under. I like to manage space a lot. One of my hobbies. Okay. So can you read out the question for me again? Can you read out that question?
0.06
Mm-hmm.
multiplied by 0.0003
Hold on. Multiplied by 0 point what?
0, 0, 0.
How many? 3, right?
4. Yes. I know
Boom.
3.
4. Okay. Like this.
Divided by 0.01.
Divided by 0.01. Okay. Okay, so there are 2 ways I could have done this. Now, this is one way of doing it. 0.06, right? Remember, anytime we're dealing with decimal points, aim at making them all whole numbers, especially when division is involved. So this is what I'm going to do. Count how many times I need to move the decimal point to make 6 a whole number. That's already 2 times, isn't it?
Yes.
So I'll have my 6 there. Just write down 6. Don't worry, we'll come to the guy underneath. Then put your times. Then how many times does this guy need to move to make 3 a whole number? That's 4 times. Am I right?
Yes.
So I write my 3. That's what I'm going to write next. Times 10 raised to power, let's see, 1, 2, 3, 4, 5, 6 times 10 raised to power 6. Now, to make this thing balance, I must also multiply the guy underneath by what? Times 10 raised to power 6 to make it balance. So that's going to be 1, 2. Now, out of 6, right? I've already moved 2 times. Okay. So that's going to leave me with 4 times left. So that's going to be 1 times 10 raised to power 4. Do you agree with what I just wrote down?
Yes.
Do you agree with it?
Wait, where's the writing? Oh, okay.
Sorry, did you get it?
Yes.
I don't know why. Did you understand what I just did back there?
Yes.
Alright. So let's go to the next bit. So the other part is to multiply the ones that make sense. So 6 times 3 will give me what? Sorry, 18. Okay. Now the 10 will now take care of themselves. Now there's a lot of indices that says when the bases are the same, right? You should subtract the power of the guy underneath from the one on top. So that's going to give me 6 minus what?
4.
So that's going to give me 18 times 10 raised to power what? 2. But guess what? This is not standard form yet until the decimal point is between 1 and 8. So what are we going to do? This is going to be further. Now you have to be careful here. If not, you can still mess things up here. It's going to give me 1.8. Now, what 1.8 and 18, what do you think happened? The decimal points moved from the back of 8 into the middle, isn't it?
Yes.
So don't forget, anytime you are wondering where the decimal point is, always ask yourself, is it a whole number or not? If it's a whole number like this, then guess what? The decimal point is at the right hand side of 8. So there's no mistake in where it is. So for it to be standard form, decimal point needs to be between 1 and 8. So that means this is 1.8 times what? Now, just watch what I'm going to do. Times 10 raised to power 1. Because that's what would have made it to go back to 18. Okay? Don't forget, I'm not done. No. Don't forget that there was already 8 times 10 raised to power 2 there. Isn't it?
Oh, yes.
So that same law that tells us that when the bases are the same and you have a division, you perform a subtraction on the powers. That same law says that when you have multiplication, that you perform addition on the powers. So this will give me what? 1.8 times 10 raised to power 1 plus 2, which is what? 3. Sorry, I'm using I'm using my mouse to write, so I'm like a board and my yeah mouse pad, so it's not may not look so legible. But can you see
Does that say 42?
that's 1 plus 2, not 42. Did you get? Can you see? Sorry, right. But maybe I should just
Oh, yeah, yeah.
remember 1 plus 2. Okay, so that's going to leave us with 1.8. Oops. Sorry, 1.8 times 10 raised to power 3. Yeah. So, are you good with that?
Oh, yes.
Okay. So, should I stop sharing my screen or you want to write down anything?
Yes, I'm just writing down the last sequence.
Okay.
Oh, yes, I'm done.
Okay. So, I'm going to stop sharing my screen now so we could see yours. Okay. Here is a list of ingredients for making 16 flapjacks. Hmm. Question. Jenny wants to make 24 flapjacks. Work out how much of each of the ingredients she needs. Wow. Hmm. This is a big one. Okay. Not too big for us to handle. Okay, let's take a look at the thing critically. It says for 16 flapjacks, we need 120 grams of butter, 140 grams of brown sugar, 250 grams of oats, and 2 tablespoons of syrup. Now the thing is this, right? Um, hmm, if you are thinking what I'm thinking, someone may be thinking of finding out. So what would what would Jenny, if we wanted to make one flapjack, not 16, but one, how many would we need? But we're not going to take it that way. This is what we're going to do, right? 16 flapjacks. Let's try and see 16. Or yeah, let's try and see if we can see 16 in 24. Let's look at it critically. Did you observe that 24 is 16 plus 8?
Yes.
Now, with that analysis I just did now, you know that this question is already solved. This is how I'm going to do it. If I know how many of each ingredient I need for 16 flapjacks, then obviously for 8 flapjacks, I would simply find half of each one, isn't it?
Yes.
So, let's work it out. For for 16 flapjacks, I need 120 grams of butter. Then for 24 flapjacks, I would need 120 grams of butter plus half of 120. That is what we'll need for 8 flapjacks. 120 plus 60 is 180. So for butter, you can put 180 there. Okay. I hope you understand what I'm doing now.
Yes.
Good. Let's do the same thing for the next one. 140 grams of brown sugar plus 70. That is 210 grams of brown sugar. Okay. Moving on. For oats, we have 250 grams of oats plus 125 grams of oats. So that's going to be 250 plus 125. I'm still doing this mentally. It's going to be 375, right?
Yes.
Okay. And finally, 2 tablespoons of syrup. That's the easiest. 2 plus 1. Half of 2 is 1. 2 plus 1 is what? 3. Isn't it?
Yes.
Excellent. So that's it. Now, did you notice how I started my thought process? Somebody would have been tempted to think, oh, let me find out what it would cost to make one flapjack. That would have been a very tedious process. And I assure you, it the person may not finish it before the exam is over if you wanted to solve it that way. So it's always good to look at your question critically, see how you can make it as easy as possible for yourself. All right. So, are you done writing down the working for that?
Yes.
Okay, so let's move on. Okay, this guy looks like a probability. Okay, sorry, I thought it was probability. Okay, so Harry, Reagan, and Keelan share 450 pounds in the ratio 2:5. And that says how much does Keelan get? Well, Keelan's part of the ratio is 8. So what we'll do first is to add everything up, right?
Yes.
Then we say 3 divided by the total, which is 10. 3 over 10 times 450. What would that give us? The 0 in 10 will cancel the 0 in 450, leaving us with 3 times 45. That's it. It's already done. 3 times 45 is 3 times 5, 15. 3 times 4, 12 plus 1, 13. That's 100 and, yeah, 135, right? Have you confirmed the answer? Is it 135?
Sorry, for which one? Yes. Keelan has 135.
Uh, okay, so let's move on then. Okay, since there are three cards of A and three cards of, there is a number of each card. What does it say? Ryan takes a card, takes a random, I think you wanted to say takes at random the card from box A, okay, and the card from box B, okay. It says he adds together the numbers on the two cards to get a total score. It says work out the probability that the total score is an odd number. All right, so now for this kind of question, you have to be careful with it because you need to establish the chances of getting totals now. It's not just the number of cards in the box. Okay. So remember the formula for probability is what? Do you remember?
Um,
Number of the cards outcomes divided by number of possible outcomes.
pardon?
Okay. Number of required outcomes over number of possible outcomes. Okay. You may need to write that down so you remember. I think we did that once while you were still here back then. Okay. So the number of possible outcomes is okay. So let's look at it critically. Imagine you pick let's see, 3 and 9, 3 and 2, 3 and 3. That's a possibility, right?
Yes.
Now, I hope you notice I'm not looking at the sum yet. Okay, I'm not looking at the sum yet, but I'm looking at how many occurrences that is. Okay, so let me say it again. This is possible outcomes. Now I'm counting 3 and 2, 3 and 9, 3 and 3. That's a possibility. So that's three already, isn't it?
Yes.
Let's see the next one. 4. You could have picked 4 and 2, or 4 and 9, or 4 and 3. Another 3. Altogether 6, isn't it?
Yes.
Finally, you could have done 5 and 2, sorry, 5 and 9, 5 and 2, or 5 and 3. That's the third possibility, making it 9 altogether, isn't it?
Yes.
Good. Now, take note, that 9 is your denominator for the probability. That is the number of possible outcomes. Now, let us zero into the question. The question said, what are the probability of the total score, that the total score is an odd number? Now, we are only going for sums that are odd numbers. Now, let's take it from the top again. 3 and 9 will give me 12. So 12 is not an odd number, isn't it?
No.
So we throw that away. Don't count anything for that one. Let's check. 3 and 2. 3 and 2 is 5, isn't it?
Yes.
That as one. Can just I don't know how you want to keep track of that. For me, I'm using my fingers. I'll keep track of that. That's one. 3 and 2 is 5. The last one is 3 and 3, which is 6. That doesn't sound like an odd number to me. I'm done with that. So I still have one so far. Let's check. 4 and 9. 4 plus 9 is 13. That's an odd number. So that's the second count. Are you with me? Are you still there?
Yes.
Okay, good. All right, so 4 and 9 is 13. 4 and 2 is 6 again. I don't need even numbers. I need odd numbers. So I dismiss that. 4 and 3 is 7. That sounds like an odd number to me. So how many occurrences do I have now? I have 3 occurrences. If you are following my count, I have 3 fingers up now. The next one is 5. 5 and 9 is 14. Okay, so don't be tricked by the fact that both of them are odd numbers. 5 and 9 is 14. That's an even number. 5 and 2 is 7. So yes, that's another one, another finger up. And then 5 and 3 is 8. Dismiss that. So I have a total of 4 occurrences where the sum will be an odd number. So that's going to be 4 divided by 9. Did you get that?
Yes.
So that is the answer for that probability. Please confirm with the marking scheme if they agree with us. I just want to be sure of this particular question.
4/9.
They agreed, right?
Yes.
Okay, good. All right. So, but did you understand my explanation back there?
Yes.
Okay. All right. Please, if you are showing your working, I would advise that you use arrows and and then isolate the cases just the same way we did it. 3 and 9, 3 and 2, 3 and 3, and then you now use maybe you can, I don't know if they allow you to use different colors of ink on your question paper, so you'll be able to know which one is for 3, which one is for 4, and which one is for 5. Okay, so we can move on now. You are done writing for that particular one. Uh, Veronica wants to buy 35 t-shirts. Each t-shirt costs £5 80 pence. Veronica does the calculation. 40 times 6 equals 240 to estimate the cost of 35 t-shirts. Explain how Veronica's calculation shows the actual cost will be less than 240. Okay, this is an estimation question now. I think obviously we can see that Veronica um, approximated upwards, isn't it?
Yes.
So that would make it definitely more than the actual value would be less than. But I don't know how you want to explain it, but say he or she rounded up the value upwards. 5.8 was rounded up to 6. Um, 5 was rounded up to 40. So, okay. So would you be able to put that explanation in words?
Yes.
Okay, so let's move on to the next. The next question says there is a special offer that says t-shirts are 5 cents. That says buy 30 off, get 10% off the total cost. Right? Okay. Says what are the actual costs of buying 35 t-shirts using special offer? So now we're no more approximate. We are using exact value. So what are you going to do? You're going to multiply 35 by what?
Um. by 5.18.
5.8. Okay. Okay. Now, remember that now, I would advise, okay, please take note of what I'm about to say now. Let's consider the 5.80. But always remember what I said. Maybe sometimes I when you have decimal point, you can safely ignore it safely. Okay. So instead of saying, because you are the one that will be calculating it, and if you have too many digits to calculate, it's a waste of time. So you can simply do this. 5.8, you can put your 35 on top, and then put 5.8 on that. And you know the rules for that kind of multiplication. Multiply it as if there's no decimal. At the end of the day, put back your decimal point. Okay? Now, but that's not the final answer. The final answer would be, because you said 10% of the total cost. You will have to now take 10% of the total cost. Another way to do it, just multiply it by 0.9. That gets 0.94. 90%. 90% being 100% minus what? 10%. Okay. That's just no big deal. So let me know. Do you understand what I just explained, or do you want us to work it out?
No, I understand it.
Okay. That's fine. Okay, so we can move on. There are only red buttons, yellow buttons, and orange buttons in the jar. Uh-huh. The number of red buttons, the number of yellow buttons, and the number of orange buttons are in the ratio 7 to 4 and 9. What are the percentage of what percentage of what what percentage of it? I will just be back by about 50%.
Hello?
7 plus 4 plus 9, right? 7 plus 4 is 11, 7 plus 9 is 20. And you agree that that's actually one to work out.
Hello?
You agree that it's easy to work it out that way. 9 over 20 times 100 over 1.
Oval, okay.
Okay. So can you quickly do that on your side and tell me what you got as your answer?
9 over 20, correct? And then
9 over 9 divided by 20 times 100 over 1. The 100 is because of they asked for the percentage. So that's why we're saying times 100 over 1.
so it's not 45 over 100.
I didn't get what you said.
So is it 45 over 100?
Uh, not really, no. So I'm not sure why you said, is it, did you say 5 or 45? I didn't get you back there.
9 over 20, and then multiply 5, multiply 9 by 5 and 20 by 5, and I go 45 over 100.
Oh, 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 oh. Okay, okay, okay. So why not? This was how okay, well, maybe that, I don't know if that method would be faster, but this is what I thought, right? So 20, you can cancel the zeros out, and 2 will go into 10 5 times, and you're left with 9 times 5, which is 45. So yes, it will be 45%. Okay, so if we come by the same answer, that's fine. But I'm equally looking at getting to the answer quicker. So we're good with that, right? 45%, right?
Yes.
Uh, If that's good, we can move on then. I think we're making some good progress on number 15 now. Okay. Are you still writing?
No, no, I'm done.
Okay. Okay, let's move on. It says here are two fractions. Work out which of the fractions is closer to 1. You must show all your workings. What would you do in this case? Uh, That's the easiest thing I'll do. I'll combine both of them. For instance, now 7 divided by 5 is 1 number 5. And 7 in 50. I'm just trying to do the calculation in my head now. 7 in 50 is 7. Because 7 times 7 is 49. So that's going to be uh, uh, 7 remainder 1. And 1 again. So it will just keep on, to just be accruing like that. So 5 over 7 is 0.7. Now, between these two numbers, 0.7 and 1.4, which one do you think is closer to 1?
Um, would it not just be the smaller one? 5 over
Yes,
7.
the one that has the smaller difference, right? So it's not the smaller one per se. The one whose difference from 1 is smaller. So let me explain. 1.4, the difference between 1.4 and 1 is 0.4. Am I right?
Yes.
Now, let's look at 0.7. The difference between 0.7 and 1 is 0.3, isn't it?
Yes.
So which one do you think is smaller in terms of the difference?
5.5/7.
Thank you, it's 5/7. So that's so so you have to prove it by what? First converting them to what? Decimal. Did you get that?
So I have to convert them to decimals.
Yes. Is this something you can quickly? Are you good? Are you good at it?
No, not really.
Let, maybe let me show you how I came by my. Let me show you how I came by. Okay. I'll share my screen now. Just for you, it's a very simple process. It's my screen now. It's my screen. Let's confirm if you can see my. Hello.
Yes.
Okay, good. All right. So here we go. We have two numbers: 7/5 and 5/7, and they're asking us which one is closer to one. Okay. So 5/7. Okay. Remember, it's like saying 5 divided by 7. If you are using long division style, this is how it will look. 7 outside, that's the denominator outside, and what inside? 5 inside. Are you familiar with it?
Yes.
Just, I want you to just observe what I'm going to do. It's not a big deal. 7 in 5 is 0 point because, of course, you know that 7 is bigger than 5. 0 point, you put your 0 behind the 5. You now say 7 in 50. We know that 7 in 50 is 7 times, okay? Because 7 times 7 is what? 49. That's the closest we can get, okay? We have 49. 50 minus 49 is 1. Guess what we will do? We'll stop our calculations there, okay? Let's go to this other guy, 7/5. Now, let's try and, uh, okay, maybe we should just do the same thing with this. So let's say, sorry, I'll remove my calculation for this one to this one. So 5 is 7. Let's just put 5, right? Because 5 is the denominator now, and 7 is my numerator. So let's just do 5, 7. Okay, so let's go. 5 in 7 is one whole number, right? 5 times 1 is what? 5. So this was not even how I wanted to. Sorry, let me back up. Sorry, let me back up. This is not how I wanted to do. Okay, so the difference in this one, I don't know whether you can notice the difference. In this case, 5 is less than 7. Did you notice that?
Yes.
Good. In this case, 7 is more than 5. So just, I want you to see what I will do first. When you have a scenario where the numerator is bigger, I would go like this. 5 into 7 is one whole number. Remember what? 2 over what? Over 5. Now, you know what I'm going to do next? I'm going to work on this part that has small number over big number, the same way I did with this. But I would forget that I already have 1. Don't forget that. So I'm going to go like this. So I'm going to go like this. Um, 2/5. That's going to be. Let me just so that I don't forget that 1 is there. 1 plus 5 into 2 is what? Same thing, 0 point. Then just like we put the 0 behind 5 back then, we're going to put the 0 behind 2. And it will now become 5 into 20, which is what? 4. And in this case, we're fortunate. 4 times 5 is what? 20. So things quickly play out. Just like you did minus back then. You did the minus operation. So 20 minus 20 is what? Is
0.
empty. So that's it ends there. So the final answer is going to be what? 1.4. Now, the final answer for this one is 0.7. Now, if you remember what that question said, the question said, which one is the closest to 1? And the closest to 1 means the one whose the difference between it and 1 is the smallest. So, looking at this, if you want to establish it, you can come here and say, find out the difference. 1.0, right, minus what? 0 point what? 7, right? And for this one, because it is bigger than 1, we're going to be saying 1.4 minus what? Minus 1, 0. Do you agree with this so far?
Yes.
0.4. And then that's going to give me what on this side? 0.3, isn't it? Do you agree with that?
Yes.
Can you now see clearly how we came by our judgment using decimal? Do you agree with me that it's easier to use decimals to see the clearer picture of which one is closer to 1 than any other method? Okay, do you have any questions?
No.
Okay, so what I want you to take away from this question is that method of getting the decimals whenever you have a smaller numerator and a bigger denominator. Would you, does it look more familiar now? Would you be able to remember it? Okay, all right. Okay, so it just see, it looks like long division. I'm sure if I use the long division, this kind of thing will be. The only thing is just remember that when you have a big number and it's going into a small number, the first thing you start with is 0 point. Then you now put a 0 behind the other number, and then you can continue the long division. Okay, so are we good to continue? I know it's past our time, but let's see how many questions are still left so that we can quickly get to. It says there are 30 children in the nursery. One adult is for every 8 children. What are the least number of adults in the nursery? How many kids are so big about it? So, like say 30 divided by 8, and we know that 8 times 3 is 24. 24, sorry. will remain. That's 6. So that means there are 3 groups of 8 children. And since each 8 children give us, we need 1 adult. What does it mean? It means we will need 4 adults. Okay? The 3 adults will take care of the 3 groups of eight children for the 24. Right? Then the remaining 6, 1 adult will not take care of that 4 altogether. Do you agree with me?
Yes.
This is a mental question. Oh. I didn't write down a single thing. Totally mental. So you can see your multiplication table will really save you. I mean, a great deal. Questions like this. Very simple. But of course, it's out. So I'm showing you what says 4 children join the non. Because this means that nothing. Obviously, no. Can you tell why? Can you tell why?
Hello.
Are you there?
Yes. Hello.
Yes, can you hear me now?
Yes.
Okay, I asked the question. Did you hear my question?
No.
Okay, I said, look at that second question very, very well. It says two more children join the nursery. Does this mean that more adults are needed in the nursery? Do you think more adults will be needed for those 2 that just joined?
Yes.
Now, I beg to disagree with you. Do you know why I disagree with you?
No.
Now, let me just listen to my own argument, though. Just listen. Remember, when we had 30 children, right?
Yes.
And we said the question told us that 8 children per adult, 8 children to 1 adult, 8 children to 1 adult. And we said that if you work out how many adults you will need, you will need 4. How did we get 4? This was how we got 4. 3 adults will be needed for 8. That's 24. 8 times 3, 24. But since that there are 30, the remaining 6, 1 adult can handle them, isn't it?
Yes.
Remember, they said 8 children to what? 1 adult. This last adult, the 4th adult, eh, has how many to handle? 6, isn't it?
Yes.
Don't you think that those 2 that will now join the nursery will simply make up that 6 to become 8?
Yes.
So that means we don't need an extra adult. Do you agree?
Yes.
All right. So can you see the reason for my own answer? Why I would clearly say no, we don't need more adults. The question said 1 adult is needed for every 8 children in the nursery. Uh-huh. So if we follow that fact that the question gave us, then obviously we don't need an extra adult. The last one, the 4th adult, can take care of the extra 2 that come in, making it exactly 8. So are you good with that answer so that we can move on? Okay. All right. I think you did very well with this key diagram. Uh, it says Jake played a different game. It said it's modal score. Okay, you can handle that one. Okay, all of them seem to be connected. Okay, Jake said his modal score was 6 points because six occurs most often in the diagram. Is Jake correct? Well, it's a
Wait,
leaf
what question are you talking
diagram,
about?
right? What did you say?
I said, what question are you talking about?
Okay, I'm looking at number 10 now. I don't know. Okay, are you skipping number 10?
Yes, because I understand it.
Okay, you understand it. Okay, cool. Okay. All right, I'm looking at 9 now. Or do you want us to move beyond 9?
Um, yes, yeah. Um, yeah.
Okay. The graph. This one is plotting graph. Coordinates for point A, 6 minus 2. It's simple. That one is easy. The coordinates on x-axis must come first. 6 comma minus 2 in brackets. That's it. 6 comma minus 2. That's the answer for that question. Did you get that?
Yes.
Okay. It says here are 5 straight rods. All measurements in centimeters. The total length of the 5 rods is what? Capital LCM. Okay, LCM. It says find the formula for L in terms of A. Okay, write your formula as simple as possible. There is no big deal about this question. You're just collecting like terms. Simple, simple. Formula for L. A minus 1 plus A plus A plus A plus A plus 4. Finish. If you sum up all the A's there, I have 1, 2, 3. How many there? 1, 2, 3, 4, 5. So the summary of this formula is going to be 5A. You have minus 1, you have plus 4. Minus 1 plus 4 will give you what?
3.
Plus 3. Thank you. So that's going to be 5A plus 3 equals L. Simple. That's the formula. This question is probably one of the simplest questions. If you want to show your working, it's just a matter of collecting like terms. That's all. No big deal at all. Did you get it?
Yes.
All right. It says here are the first 4 terms of a number sequence. It looks like yeah, 2 plus 3, 5, 5 plus uh, 6, 11, 11 plus what will give me 23. That looks like 12, right? Yeah. Okay. So what does it say? The rule to continue this sequence is multiply the previous term by 2 and add 1. Okay. This one is simple now. Multiply the previous term by 2. So 23 times 2 will give me 46, right?
Um,
46 plus 1 will be 47. So that this one is quite easy. They even gave you the rule. If it were in some exams, I know nobody will give you the rule. You just you have to figure out the rule first by yourself. Then you can now you can now find the fifth term. But yeah, I guess maybe because this one is foundation, that's why they gave you the rule. Okay, so did you understand it?
Yes.
Okay, all right. We can roll. Can move on now. Let's go. Okay, it says here. Okay, which one should I even do first? Okay, let's. This is the last one now. Okay, so it says here are four numbers: -9, -2, 2, and 9. It says which of these numbers in each box? Sorry, I didn't get that. Write one of these numbers in each box to make a correct calculation. Oh, okay, I know. I noticed something. The first few questions, maybe like the first page, the questions are quite easy though. Could be tricky for some, but I bet you they're quite easy. So what would I add to give me -7? What two
Um,
numbers will I add to give me -7?
-9 plus 2.
9, 2. Excellent. Correct. Perfect. Okay. It says solve y over 4 equals 5. Do you remember when we solved the question like this? I'm talking about number 3 now. Do you remember when we solved the question like this? Looking for y, right? You want y to find the value of y, but there's a 4 underneath. What should you do to take care of that 4 underneath? You simply multiply both sides by 4, right? Because if you multiply the left hand side by 4, 4 will cancel itself, isn't it?
Yes.
And of course, when you multiply the right hand side by 4, you have 105 times 4, which is 4 times 5, 20, 4 times 0, 0 plus, plus 2 is 2, and then 4 times 1 is what? 4. That is 40, 420, right? 420. Of course, don't forget that there's a decimal point there. So by the time you move the decimal point backwards, what will you have? 42, isn't
42.
it?
Yes.
Yeah, very easy. Okay, these are giveaways, like warming you up for the main thing. 2, is that plus or divided by? I want to
Plus.
believe that's a plus. Okay, so you know your, is it board mass now? Which one do you know? Board mass or PEMDAS?
Bid mass.
Do you know the acronym I'm talking about at all?
Yes.
Yes, board mass, yes. So your hierarchy of, so yes. So which one do you think will happen first?
7 times 10.
Yes, correct. 7 times 10 will happen first. So that will be 7 times 10, 70. 2 plus 70 will give me 72. All right. Finally, change 365. These questions are quite easy. Change 365 centimeters into meters. If you remember the conversion measure, it tells us that 100 centimeters make 1 meter, isn't it? So that means that if I'm going to convert from centimeters into meters, I'll be dividing by 100. Okay. So let me ask you a question. Now I need you to be as honest with me as possible, right? When it comes to conversion units, do you have problems telling whether you are to multiply or divide by the factor? Do you have any problems with that?
Yes.
Okay. All right. So let me just quickly share my screen and explain what I just did back there. Please just watch my screen. You will see that it's not difficult at all. Just confirm that you can see my screen. Can you see my screen?
Yes.
Okay, good. All right. So here we go. What I said back there, they said we should convert 365 what centimeters to what meters. Okay, centimeters convert it to what? Meters. Let me just say X meters. So the question is to what were centimeters and meters, what links them? And of course, it means that you need to remember these things. 100 centimeters. Okay, just observe what I'm doing. 100 centimeters equals one what? Equals 1 meter. Okay, so um now I want you to see what I'm going to do now. You just observe 100, 1. Okay, you have a bigger number here, you have a smaller number here. Now, the question that we were asked is what's 365 centimeters in what? In meters. So that means the direction of conversion is going from centimeters to what? Is going from centimeters to meters. Now look at the conversion measure. You have 100 centimeters make 1 meter. If you are going from centimeters to meter, that means it's like an arrow that's pointing in this direction. Okay, from centimeters to meters. That's from the left hand side to the right hand side. Now, on the left hand side, I have a big number. On the right hand side, I have a small number. That tells me that if you can only do two things, either multiplication or division, what will make a big number become a small number? That would be division, isn't it?
Yes.
So that will tell that from centimeters to meters, that's going from centimeters to meters in this direction, is going to be what? Division. So that means all I need to do is to do what? Divide 365 by what? By 100. Did you see that?
Yes.
You already know this guy now. Anytime you are dividing by powers of 10, decimal point will move from where? The end,
Up
the left hand side,
to the left.
according to the number of zeros, isn't it? So that's going to give me
3
3,
point.
5. Okay. So based on what I just explained now, right? What
Yes.
if the question had been to convert from meters to centimeters? What would you do? What would you do?
Multiply.
Thank you very much. You would
Multiply 100.
multiply, you multiply 100 by 365, isn't it?
Yes.
Okay. And the reason why you're multiplying is because you are going from meters to what? Centimeters. That is from the right hand side to the where? To the left hand side. And then you're going from a small number to a big number. And what's the most likely operation that will get you that? Multiplication. Okay. So that's just an easy way to remember it. Okay, so now can you do the next one for me? Let's see if you can. I'm going to stop sharing now. The next one is another conversion question. Let's see what it says. It talks about grams to kilograms.
This
Says
one
that
is uh, times 1000.
yes, correct. Times 1,000, correct. That's it. Yes. And you know what will happen to the 2.7, right? Decimal point will move to the right 3 times. So that's going to give us 2,700 grams. Okay. So you got any questions?
Um, no, no, no. No.
Okay. All right. I think we've done pretty well with our time today. We overlapped a bit, but it's fine. I think were able to cover ground. So what's your the next exam you're taking?
English.
All right. Okay. So I guess you have time to prepare for that. Okay. So I'll check. I'm not too sure when our next class is. Um, Saturday. Oh yeah, Saturday is true. We said 10 to 12, right? I just remembered now. Okay. So yeah, that's tomorrow. So we'll meet tomorrow 10 to 12. Okay. All right. So what subject do you think we should do tomorrow?
Um, Science.
We have a science. Okay. Okay. Which one in particular? Chemistry or physics?
Um, Physics.
Okay. All right then. Work towards it by God's grace. Get it done. All right. So have a good night rest. Try and get some rest so that you'll be strong for tomorrow. All right. Have a good night.
Okay, thank you. You
All
too.
right. Welcome. Yeah, bye.